I don't know why it just did that. It's probably been sitting there. Yeah, that's what mine looks like too.
Okay. So I mean, I personally kind of would just say that it's positive and strong, but I don't know if that's right.
Let's go down. Whoa, silly computer.
My heavens.
Notice that there's a strong positive linear relationship between the, okay. I would say, okay, we say that the direction of data in a scatter plot is positive if there's a positive association between two variables when an increase in one variable tends to lead to an increase in the other. So yes, I agree it's positive because they tend to take the upward slope at the same, pretty much the same. And then strong. We also describe relationship between two variables as weak, moderate, or strong, depending upon how close the relationship is between the variables. So they're pretty close because it's 0.9 and 1.
Okay, so it's those two numbers that we're comparing?
Mm-hmm.
Okay, that's what I was a little confused on.
If there's a strong positive association, the correlation coefficient will be close to 1. So there we go. I think you are correct. Positive and strong.
Okay, now we gotta match the scatter plot with the correlational coefficient.
Okay, so we've got, I gotta go over here and move it just a little so I can see better. Okay. I think it's B.
Wait, what?
What? Hold on a minute. What?
So are you looking at number 8?
Yeah.
Okay, so for the first one I have is R equals 1. I did that for number 1.
Okay, hang on. I see what we're doing. R equals 1 for why is that open? Okay. And then 2 would be the 0.95, right?
Yes. And then 3 was R equals 0.
Right.
And then 4, I did R equals -1.
Yep.
5 would be the R equals -0.95. And 6 is R equals -0.6.
Oh, there it is. I was looking for that. That's funny. Okay. Yep. All right. So then we can get out of that one.
I'm opening up another SPSS for the new one.
Uh-huh.
So give me just a minute.
Okay. Oh, open up there. There we go. Okay. That. Okay, so the coefficient and then the direction and strength. Okay. So analyze point bivariate. Okay, I got 0.728
1 second.
as the coefficient.
And still loading.
Okay.
Hmm. Are we just doing confidence rating mean for variables? But you
Yeah.
need and score?
Ma'am,
What?
I didn't hear what your question was. Confidence rating mean and score. Yes.
Okay.
And then shotgun blast.
I got 0.728 for score.
Yep.
Okay. And then let's go ahead and do a scatter plot.
I wonder if I think it's weak, but I don't know if it's positive and weak or negative and weak. Let me go back here.
So I would say positive and weak.
Yeah, that's what I have.
Or, yeah, positive and weak.
Because it looks like it's going on the positive side, you know?
Yeah, it looks like it's going up, but it's so spread out.
Okay. Let's see if that says anything. Um, yeah, I still kind of think positive and weak. I'm not seeing anything in the lesson that would change my mind. I'm going to submit and see what happens. So we can move.
It's positive and strong. That's the only one we got wrong.
Is it strong?
Well, I guess if we're going off of the 0.728, then I guess that kind of is a strong number because it's closer to 1.
Well, I guess so. Now, do we take that from like above a 0.5 versus?
I would assume it said in there that there was no cutoff of like this is considered weak, this is considered moderate, and this strong.
Yeah.
So, I mean, I guess if we just based it off of, because I was just basing it off of how the graph looked, but if we go off the number, then it should be, I guess, strong.
Yeah, that makes
So,
sense. Awesome. Okay.
okay, so there's one done.
Yay. All right, Okay, let's move on to 22.
Give me just a minute. Okay, 22. Please don't be a lot. It's 15. That's not too bad.
Oh, come on. My computer's just sitting here like it doesn't want to do anything. Got it. Okay, got it. Come back and put that up there. Okay. 22. All right, let's see. Do I have that right? Okay. So we may need the probability applet here, which always makes me excited.
Oh, yeah. Okay.
Given the linear regression equation, sorry, right as that happened, my SPSS popped up. Okay. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? Is that just the standard xy? I have to look that one up. I don't remember. I didn't. Let's see.
Well, if you solve it just like that, it would be 3.5, which we are rounding to 1 decimal point.
Yeah, but I don't think it's that simple if we're working on a y and an y-axis. Okay. X represents. Oh, that's got y hat. Well, I am not even comfortable with this. Okay. And it doesn't give us an x equals anything. It's just, okay. So maybe it is
Yeah.
that simple. Go back. Okay, so
Oh,
where what? Go ahead.
what is the slope now? Oh gosh, hold on. Oh,
Things that you have
hold
like
on.
graph paper.
Hold on. Okay, I know what we did. So if you have the equation y hat equals bo plus b1 times x,
Uh-huh.
so bo is the y-intercept, so that would be 2.0.
But this isn't y hat yet. This is just
Yeah,
y.
yeah, but so still the y-intercept is the 2.0
Right.
because slope is 1.5. So in question 3, it's just asking you what number in the equation is the y-intercept.
Huh.
And then
Is
at
it
number
that?
4, it says, given the linear regression equation y equals 2.0 plus 1.5x, what is the slope? Well, slope is 1.5.
And so it's 2.0 and 1.5. It's that simple? Really?
Yeah, I think it's just trying to figure out which numbers are what in the equation.
Wow. Okay. And then this one, so what we would do is we would take this one, sorry, question 5, given the linear regression equation, y equals negative 3.0 plus 0.25x, what is the predicted value of y when x is 16? So you multiply 0.25 times 16, which would be 4. So it's going to be 1.0 because it's negative 3 plus 4. Does that make sense?
So, yeah. Okay. For the next 7 questions, use the data file math self-efficacy. Okay. Be sure to use the confidence data for the explanatory variable and the score data as the response variable.
All right, so we're going to analyze this, correlate, bivariate. Did I get the wrong thing?
Let's see. Make a scatter plot.
I think, no, that's the same stuff we did before. That's funny. Okay.
Yeah. Okay, so it said to do confidence as the explanatory. So I need to switch these.
What? What are you doing? Am I missing something? I'm missing a step, maybe?
Oh no, so I had it pulled up from the last group quiz.
Oh, gotcha.
So this one, it says to use the confidence data for the explanatory variable. So that's going to be the x-axis, and the score data is the response variable is the y-axis, and I had them flopped.
Okay.
So I was just unflopping them.
So it wants score as x, right?
Score as y.
Sorry.
Confidence as
x. Okay.
And it should be a hot dog shape, I think.
Mine is not really.
This is what mine looks like.
Yeah, that's what mine looks like. Exactly. Awesome.
I say it looks hot dog-ish.
So, well, it's not a banana. I guess a hot dog makes more sense than a banana.
A hamburger, I feel like it'd be more like everywhere.
Round. Yeah, it would be round. Okay, so we agree on hot dog.
Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data?
I say it's not reliable, but that's because I'm not sure if that's right.
It's not reliable or it's not appropriate.
Well, I don't know. I would say not reliable because of the outliers,
Yeah.
but the verbiage may be that it's not appropriate. Let me look down through here. Did we do regression linear? Analyze regression linear?
2.4, interpreting the regression output.
Did you do that? Analyze regression linear? I didn't do it that way.
I just
I
did a
did.
scatter plot.
Yeah, let's go back and do this. Okay. So
Oh, okay.
regression linear, and then it asks for the dependent and the independent. Oh boy, let me go.
So the dependent would be confidence rating. No, it's score, right?
I don't know.
And I think confidence rating is independent.
Okay. And so then it's going to ask, what do we want if you go under plots?
Oh, okay, hold on, wait. So it says independent is the one that we're predicting. So yeah, I think that was right. Okay.
Do we have to go under plots or statistics or options? I don't think so. Do you?
I don't think so.
Okay, let's see what happens. So the regression linear.
I just got a coefficient little table.
Yeah, basically it's the same thing, isn't it? Oh no, that is the same. So the graph. Weird. Did you get a different scatter plot when you did that?
No, let me make a new one. Let me see.
Because all I got was the coefficients and the ANOVA and the model summary under regression.
I didn't get a new scatter plot with it.
Yeah, neither did I. Okay.
I think the scatter plot's going to remain the same.
Okay. So now the simple linear, based on the shape of the scatter plot you produced in the last question, what would you say about the appropriateness of using simple linear regression to model these data? Okay. Huh. I still am sticking with I don't think it's appropriate.
It's not appropriate or it's not reliable?
Oh, what did I say before? Let me go back to my quiz.
You said it's not reliable before.
Huh.
Which, to me, that sounded pretty good.
I think it's not reliable because I think our data is so different. Did you look at the, yeah. Huh. I don't know. I think it's not reliable, but it could be not appropriate. I don't even know. It doesn't tell us when. Like I was trying to find in here where it would be important or, oh my gosh, that scared me to death. Hang on a second.
Okay.
Hello. So, I probably should. I don't know. I just want this lesson to tell me more about that. And it really, really doesn't. Okay. This thing is acting up again. Okay. It just talks about the manatees. I love manatees. I think they're so cool. Okay, so this talks about how this, oh, come on, it went way too far. Sorry.
Okay.
What's that thing doing? Under the manatees and powerboats at the bottom. Are you okay?
Yeah, sorry, my back is hurting and I just grabbed a pillow for me to kneel on.
Okay. So this says, hang on.
Under manatee powerboats.
Yeah, it says we can use simple linear regression to model the relationship between the powerboat registrations and the manatee deaths. So it's two different variables. Before conducting a regression analysis, it's important that you first create a scatter plot to visually examine the data. Thank you. If the cloud of data in your scatter plot shows a curvy linear pattern, it is not appropriate to conduct simple linear regression. So basically, and then it shows, ours is more of a hot dog shape, that's for sure.
So that it would be appropriate then.
It would be appropriate. So it would then be, yeah, not reliable.
Not reliable,
Well,
but it's not oddly shaped.
it's appropriate for this data. You're right. The shape, it's appropriate. So there we go. And then number 8. How many observations are in the data?
Is that where you just go and you count how many things they have? Because it's 139 if so.
Yeah. And it should tell us in something that we have. All right. Yeah, 139. All right. What is the y-intercept?
The y-intercept is, if we go back to that. So, oh wait, went too far. Oh, where'd it go?
the y-intercept.
Hmm.
I don't know what it's asking. It's asking, but
So it wants to know what the y-intercept is, but the y-intercept would be that BO number in the equation,
yeah.
which is a coefficient. So hold on.
Okay. I see. Correlation is significant at the 0.01 level to tail.
I think it's this part. It's just above. It's right around the 2.4. I think that's where you do the analyze regression linear. Let me see. Let me see if it'll work.
Isn't R, wait a minute.
Because then if you go under the unstandardized coefficients, because it says to find the estimated regression coefficients BO and B1 at SPSS, do the following. The output from the commands given above will include a table similar to the one shown here, which is this one. Here, let me show you. Oh, well.
Whoa, I don't have anything that looks like that on mine.
So if you do analyze, what is it? Analyze regression linear. Do you see that on my screen?
I have, yeah, I see regression linear. And I did that already.
Yeah, so then what in that little table thing, it says unstandardized coefficients, and then there's the B and it has constant, and this one has head length and the thing. So our constant would be the 18.690, and the confidence rating mean would be 12.695. So in this one,
Oh, okay.
the Y, whatever, it's the 18.690. Where are you going? Okay. All right. Love you.
And then the slope would be the 12.695.
Yes.
And then
What is the predicted value of Y when X equals 4? So then we just multiply those together. So 12.695 times by 4 plus 18.690. I got 69.47.
I guess I could use my calculator instead of trying to do everything longhand. $69.47.
Oh, maybe no, that's right. That's what I got.
Mm-hmm.
Yeah, 69.47. So I do
What is the
470.
Are we doing plus X?
So you do 12.695 times 4, and then you plus the 8.
And we add it to the Y?
Yeah, the 18.690.
So it's, oh, because it's y equals, I got you. All right, whoa. The coefficient data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What's the maximum predicted value of y for these values of x? Positive correlation. Wouldn't the maximum value of y be 1? Because it's negative 1 to 1.
I don't know.
That one is, okay, let me go here. Let me look.
Confidence data?
It's data, the confidence data. So we've got to go back. Resulted from students evaluating their confidence. I have no idea, to be quite honest.
Yeah, me neither.
Because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. Okay, so the largest x would be 6. If it's a scale of 1 to 6. Okay, linear regressions allow us to predict values of y for a given x. This is done first by calculating the coefficients b0 and b1, and then plugging in the desired value of x and solving for y.
So do we need to add first and then multiply by 4?
Mm-mm.
No?
No.
Okay, well then this makes me think because there's a positive correlation, we can use the largest x value to find the largest predicted value of y. So before we multiplied by 4, so do we multiply by 6 then?
I would think so.
Okay, that sounds good to me.
So are we saying then the maximum predicted value is 6?
Oh, I thought what we were doing is taking the 12.695, multiplying that by 6, and then adding the 18.690 to it. And whatever that high value is. Because we have to round it to 3 decimal places, and this would be 94.86. I don't know.
I don't either. I'm gonna have to ask that question for number 12. But, so you're saying that this is still part of the other questions. The way I read this, it was the confidence data resulted from students evaluating their confidence for each question on a scale from 1 to 6. What's the maximum predicted value of y for these values of x? In my thought, I'm thinking that it's like just a generic thing on a scale from 1 to 6. that we weren't using anything prior. But it makes sense that we would use, you know.
Well, before question number 6, it did say the next 7 questions.
Okay,
And
then.
this would be the last question for that.
Okay, so we've got the 12.65 times 6.
Times by 6 plus 18.690.
690. So 94.860.
Yes.
Okay. Okay. So then question 13, how many exemplary or explanatory
Or independent variable.
Or independent present simple linear regression?
Independent? There'd just be one, right?
I would think so.
And then 14, how many response variables are present? Isn't that just one?
I think so. I mean, be more. I don't, you know what I mean?
Because like these ones are your generic ones, like the generic questions that they'd be asking.
Mm-hmm.
So you have one response and you have one like one reason and one response to things usually.
Right.
I would say it's one on each.
Okay.
I'm sticking to it.
Excellent.
Okay, a company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning, the company wants to predict size of the hat given the circumference. What is the response variable? Well, it'd be the size of the hat. Because it's the one being predicted, the response.
Yeah. So it'd be the size of the hat because it's being used to predict the circumference.
No, so they're using the circumference to predict the size of the hat. So the company wants to predict the size of the hat given the circumference. So what is the response variable, which would be the size of the hat? Because that's the one they're predicting. I think. I'm going to submit and see what happens.
Okay.
Yep, it's the size of the hat. And we got 100%.
No, we didn't.
Yes, we did.
Okay, so it's the size of the hat because it's the variable being predicted, or
Yes.
it's being used to predict the circumference?
The very first one, the variable being predicted. Dang, we're so good. Are you out of B yet now?
Yeah. What was that?
Said, are you at a B yet now?
I hope. I don't know. These things don't have much weight.
So I checked my grade after submitting both of them, and they only go up 0.1%.
Oh my gosh, I can't believe we got that. Okay, let me check. Let's see. No. I'm better. I'm 79.64. So I've got.
You got 0.38. There you go.
Yeah. It'll be this week.
You got this.
Yeah. I'm scared to do homework though. I don't want to wait. I'm going to do it tonight.
You know, if it's easy, kind of like these group quizzes were, I think that you'll be fine. But if they start throwing in some curveball stuff, then
Yeah.
we're both in trouble.